Let's take a look at calculating a mathematical series using recursion. Okay, well, we got from n is equal 1 to 3. What we do is go through, and at first n is equal to 1, so put 1 in for n. And then this notation means we add it together. So then I got 2 times plus 1 over. Now first n is equal to 1, and then you increase it. So n is equal to 2. And we're adding these together. So that's what that notation means. Now sometimes you're given that direct. Sometimes you have to write out the pattern like this, and then try to come up with this, or they give you the pattern, I should say, and you try to come up with this. But then we would come up with some kind of answer. Now we're gonna calculate this. We're gonna do it fairly simple, though. I'm not going to try to keep it in fraction form. So I'm gonna change it to decimal. Okay. So come over here. I'll do File, New Project, Java application. Next, and I'll leave it as that name, which is fine for me. Okay, and let's see, I guess I do want to import something. So let's see, import java.util.scanner. Down here in my main, I want to bring that in. So scanner input equals new scanner system.in. Okay. And guess I need an answer. So I'll put my answer. And I'm gonna come down here and public static. I'm not gonna return anything. I don't have to return anything, so I'm going to do a void, and I'll say series. Series might be a reserved word, probably not, but series calc. And then I'll pass in, what am I going to pass in? Okay, I'm passing, I guess I need the index. And I think that's possibly it. No idea. I need which iteration I'm on, I think. So let's see. Recursion really hurts my head, actually. Series calc. Now pass in the index. Let's do 3 to begin with, comma, and then I'm on my first iteration. There we go. And I think I'm going to return it. What am I doing? Answer equals series calc, and I'll say instead of void means you don't return anything, I'll say double. We're going to return a double. Okay. And then I'll say return 2n plus 1, 2n plus 1. Probably need a multiplication there, but we'll come back to that. N minus 3. N minus 3. Plus series calc index, comma, n plus 1. Okay, now that's a infinite recursion there. So let me say if n, and I sometimes have trouble getting this right, n is less than index, doesn't like something there. That's lined up with that. Let me put another one in. Maybe just... No. Okay, that's lined up with that. This has its own. This has its own. Beginning one there lines up with that. That lines up with that. I don't see any missing. It's probably right in front of me. Oh, maybe this should be at times. Aha! What I said originally, I just ignored what I said. I don't do this off of a script. I do it freehand. So, let me see. Passing in 3, 1. Comes down here. And then that's going to be calculating that. But then it'll be calling this, looking for the next one. Yeah, it looks good. I've hard-coded, which is not good, but we'll come back to that because I first want to check this. 3 might be too much. Do 2. Errors. Let's see, test project, debug. Be nice if it told me what kind of error. Public static, double answer. Answer equals series calc, 2, 1. There's the red squiggly, but my eyes are bad. We're missing return statement. If it's not less than index. Do I even need that? Probably an infinite loop if I take that out, but let's try it. Just for fun. Division by 0. Return that. Okay. Yeah, that makes sense that it wouldn't. N is less than index. Ah. Yeah, I should have stuck with that. So I don't want anything returned. I just want to call it. And then this, I'm going to say answer equals double answer. And answer is equal to 0. Void type not allowed here. Ah. So can I do it within here? Huh, doesn't look like it. Double answer equals 0. And we're going to call series calc, and that's going to return us our answer. It's going to be a double. Like that, and then we're going to return that. Okay, now let me think this through. No, I want answer here. Answer equals. Now double answer equals 0. So I don't really need to equal 0 here because I'm calculating it. Else return answer. What does it look like? Semicolon. Okay, semicolon. Sign value is never used, and it doesn't like this, which says that missing return statement. So return answer. And of course, doesn't like the fact I don't have braces now. I'm getting closer. There we go. So calculates that and then returns it. Okay, so then whatever it's called from, which is right here, and returns it. Try that. And of course, it helps if you actually print your answer. So let me try that. System.out.print answer. -1. I wonder if that's even close. 2 plus 1 is 3. 1 minus 3 is -2, plus 2 times 2 is 4, plus 1 is 5 over -1. So multiply the bottom part by 2, top part by 2, 10. That gives us 13 over -2, which should give us -6.5. Let me double check myself. 2 plus 1 is 3. 1 minus 3 is -2. 4 plus 1 is 5. 2 minus 3 is -1. Times 2, 10. 13. Yeah, -6.5. Let's see what I did wrong. 2n plus 1, n minus 3. And I'm passing in n. And continuing while n is less than index. Wait a minute. 3 divided by -2 is -1.5. -1.0. I think I am seeing why. Integer, I say, is n, but what I really want it to be is a double, I believe. That's probably won't be as easy as just changing that to double there, but let's try that and see. -1.5. Aha, that's what it was. Okay. The reason why I say that is because this right here was treating this as integer division. So instead of getting -1.5, I was getting -1.0, which kind of indicated to me, whoa, wait a minute, it's dropping the decimal, which usually is an indication that you're you got a mixture of doubles and doubles which has decimals and integers with just no decimals. Okay, now I still got another problem. I think it should be an equals. So let's try changing that and run it. Negative 6.5. Okay, that looks like it's working now. Wasn't real clean. And again, there's better ways to do this in recursion. But this is sitting there calling itself over and over. It's kind of like a loop within a within itself. Now, the first time through, let's talk about what this is doing. This is telling us how many iterations we want. So we want 2. And then this one is our current iteration, 1. That would be this first one here. So first pass through, it's calculating this. Okay. So it's coming down here. If n is less than or equal to the index, which was 2, which it is, then it comes down and does this. So it plugs 1 in for n. So it plugs 1 in here. And then adds, and then it plugs 1 in here, and we've got 1 plus 1, which is 2. So this calls series calculate again, plugging in 2 now. And then it comes down here, 2 is less than or equal to the index, so it does that again, and then calls that with n plus 1, which is 3. Comes up here, and n is now 3, and it comes down here, n is not less than or equal to index, so it just kicks out down here, and returns our answer. Now it seems weird how that's sitting there calculating it. Now how in the world, since you declare it new each time, how does it keep track of that? It has to do with recursion, because your original pass through this loop was right here, which means that whenever it finally returns, it returns back to here, and when it kicks out, then it returns your answer. So again, it's strange. Recursion will make your head hurt. It does mine anyway. Let me change this. Instead of hard coding 2, let's put in something to ask him. Okay, integer index, and I'll say system.out.print input index. I'll say index is equal to input.next int. And then down here, instead of hard coding 2, I'll put in the index. Now the summation notation you see, that little E looking thing, that always starts with 1, at least for this example. So that should be hard coded. So let's try running this now. And let me put 2 in, which I know works. I'll put 2 and press enter. Negative 6.5. Okay, I'll come down here and let's put in 45. I don't know if it handled something that big. Infinity. Okay, well, let's try something different. Let's put in 6. Infinity. Why does that come up 6 for infinity? 3. Oh, 3 minus 3. Aha. So no matter what, when it hits 3, it'll print infinity. Infinity is like division by 0. Sometimes it'll tell you division by 0. Sometimes it'll say infinity like that. It has to do with, I don't know. To be honest, I don't know why the compiler decides sometimes it'll print that and sometimes not. I understand from a calculus standpoint, when you have this 0 and this comes out to whatever, why it does what it does. But if you're taking college algebra, you may understand why it goes to infinity. So yeah, if I put 2 in, gives us that. Okay, now if I were to change this, put a plus there, now there's no way starting at n equals 1 it'll ever give you infinity. Then I could run it, and I could put in 20 and get some real huge, or not huge number, but I guess some number. Anyway, that's calculating a series using recursion. And again, probably not the simplest way. You may be looking at that, and not looking at it now, I can see some place I could clean it up a little bit.